In this video, we're going to continue our work with right triangle trigonometry. Last week, we saw how to set up our triangles. We learned a little mnemonic device, so, ka, toa, that helped us organize our equations where so stood for the sine of an acute angle is opposite over hypotenuse. The ka stands for cosine of one of those acute angles is adjacent over hypotenuse. And toa stood for the tangent of one of those acute angles is equal to the opposite over the adjacent when we are considering one of the acute angles of a right triangle where we have the opposite leg, the adjacent leg, and the hypotenuse. So let's see how this is different than last week, and actually in many ways getting to the answers is quicker and easier. So in this one we want to find the value of x in the triangle below, and I'll label these sides slowly, carefully in this problem. We'll go a little faster in later problems. So as before, I first notice that I'm dealing with sides and an angle in a right triangle. And that lets me know that Pythagorean theorem's no good. I'll have to use right triangle trigonometry. So let me label these sides. I start by going across from the right angle. That will be my hypotenuse. Then I go across from the given acute angle. That will be the opposite leg. And then the remaining side, the leg that is next to the acute angle, will be my adjacent leg. Now in here, I notice that I have a value in the opposite leg, I have a value in the hypotenuse, and an unknown in the angle. So when I look at my mnemonic device, so, ka, toa, I look for the one that has O and H, that is so, and I'll write out my equation, which will be sine of my angle is x, equals opposite, the opposite is 7, over the hypotenuse is 11. But here's where things start messing up. Last week, I was able to then type this into my calculator. But I can't type sine of x into the calculator. I don't have a way to do that. You might be able to type sine of x into your calculator, but it won't do what you want it to do. So I need to do this in a different way. We will address that by using inverse trigonometric functions. And so the inverse trig functions are basically functions that undo sine, cosine, or tangent. Now, what do I mean by undo? Well, if I go back here, I want to get rid of the sine. A common idea that students that are understanding the basics of algebra come at this with is say, okay, well, I see sine of x. If I had like 2, let me get back. If I had 2x equals 4, I just divide both sides by 2. So why don't I divide both sides by sine? So this works over here, but I cannot divide by sine because this is not multiplication. This is the input of a function, something different. So division by sine won't work. I have to do something different. Okay, so what's going to undo sine, cosine, or tangent? Well, these inverse trig functions. So the inverse of sine we will write as either sine to the negative first. Now, it's not really to the negative first, it's sine with a negative 1 up there. We'll talk about why this isn't an exponent. This is one way to write it. This is the way I will write it. But I've also seen it written or heard it written as arcsine And I've even seen some computer programs that will use the command asine for the inverse sine. And so this notation means inverse. This arc sine or asine refers to the arc whose sine is some number. And similarly, the inverse of cosine will be this cosine with a -1. Also can be called arc cosine. Also can be called a cos, depending on how you're doing it. Again, I'm going to use this notation for all of my work. And the inverse of tangent would be this tangent with a -1, also referred to arctangent, also referred to as atan. And the idea behind this is the following. So if we see that the sine of some angle is equal to some value, and I want to solve for this value, I have to get rid of the sine. And so what the inverses do, and I'll never show this next step again because I can skip over it, but I will take the inverse sine of both sides. So the inverse sine of the sine of A equals the inverse sine of B. And the reason I do that is the inverse sine and the sine will, so long as we're talking about if these angles in a right triangle, cancel out. And I will get A equals inverse sine of B. And I'm going to skip from here on out to, if I see sine of A equals B, I'll go straight to A equals inverse sine of B. So let's get back to, or I guess one more thing. This, okay, this -1. Now, you may, I'm going to go to red because this is wrong. You may know about exponents already and say, okay, wait a second. If I have sine to the -1 power, isn't that the same as 1 over sine? And that's why this really isn't to the -1 power. This is not an exponent. This is something completely different. So 1 over sine is a different function called cosecant. So don't think that this is just an exponent and that you can apply your exponent rules to it. It is a different function, a very different function. Okay, back to examples. So here's that first problem we had, and I'll go through the setup portion of all of these quicker from now on. So across from the right angle is hypotenuse, across from my given angle is opposite leg, and across or next to is the adjacent leg. I have the O, I have the H, so when I look at so, ka, toa, I know I'm looking for the O and the H. That means that my equation will be sine of my angle is x, will be opposite over hypotenuse. The opposite is 7, the hypotenuse is 11. Now, to get rid of the sine, I just use inverse sine. So if the sine of x is this, then x will be the inverse sine of this. Now, let's go to the calculator. So in here, we remember from previous lessons, if I wanted to take, let's say, the sine of 30, I could type in the 30, grab the sine, I get 0.5. Okay, great. I don't see arc sine, sine with a -1, or asine on here yet. And most of your calculators, whether they're handheld Texas Instruments or Casio calculators, whether they're your cell phone, whether you're using a computer program, will have a similar issue. But if you don't see what you want here, look for a second button or a shift button, and watch what happens when I press this. It changes sine into sine to the -1. This, and again, not to the -1, but inverse sine, inverse cosine, inverse tangent. And as a little check to make sure your calculator is doing things correctly, if I take the inverse sine of 0.5, so press second, press sine, I should get 30 degrees. Okay, so let's use this to get my answer. So I need to do 7 divided by 11. For the calculator I'm using, once I press second once, it will leave these in the alternate format. But if you don't see what you need there, you can press second each time. Most calculators need you to press that every time. So the inverse sine of that is approximately 39.521. So I'll get 39.521. And the final bit here. So you notice that there is no degrees marking here. What that means is I will put a degree marking here to show that this is the measure of the angle. I'll talk a little bit more about that in the next example. Okay, going on to the next example. I have my angle, and I can mark up the sides. Across from the right angle is hypotenuse. Across from the given acute angle is opposite. Next to that, the remaining side is adjacent. I follow the so, ka, toa. Notice I have H and I have A marked, which means I'm going to be using ka. So that tells me the cosine of my angle is x, will equal the adjacent 4 over the hypotenuse 5. To get rid of the cosine, I'll do the inverse cosine of both sides. Get x equals inverse cosine of 4/5. And then I'll go to the calculator. And I'll type in the 4/5. Now notice I'm still able to do the inverse, but I can turn them back on and off with the second button. So I'm doing the inverse cosine of that. And I get 36.8698, which rounds to 36.870. I need the degrees, as you can see, because there's no degree marking there. Before I move on to the last example, let me address this a little bit more. So in all of the problems we're seeing, the ones that I've made for the worksheets, I don't see a degree marking up here. But you may see on something like an SAT or other quizzes or tests that you might have a side marked like this with a variable, but the degree is already there. If I had something like this, went through this process, it would now be sine for y. I would get that y is approximately 53.130, but I would not want to include the degrees because if I put this degrees here, when I put the y back in, I would get 53.130 degrees, and that would not be correct. So keep an eye out for that. Most people don't mind too much, but if I'm measuring things in degrees, I need to have 1 degree marking on things. Okay, last example, same as before. Here's my given side, given angle. Mark up the sides. There's the hypotenuse. There's the opposite. There's the adjacent. I see I have the opposite and the adjacent, which shouldn't be a surprise to most of you. You've been in school for a long time. And when looking at so, ka, toa, you said, well, my math teacher did a so problem. That was the first one we did. Math teacher did a ka problem. That was the second one. Well, I guess we got to do a toa problem now because we have O and we have A. So yeah, we'll do a tangent problem. I write the equation. So tangent of my angle, x, is opposite over adjacent, 7/9. I will do the inverse tangent of both sides. So x is equal to the inverse tangent of 7/9. And I'll go to the calculator, type in 7/9. Take the inverse tangent. Again, my calculator is still in that mode, but you might need to press second to get there. And I get approximately 37.875 degrees. And that's it. One thing to be concerned about, or to make sure you're not mistakenly connecting, is that all of our problems we had got us answers in the 30s. I had 37.875 here, I have 36.870, I had 39 for the first problem. But that doesn't mean that every angle has to be in the 30s. Notice If I were to solve for y, I would get 53.130 degrees for this angle measure. So these angles, these answers for right triangles can be anywhere between 0 degrees and 90 degrees. Because they're in a triangle, I've already taken up 90 degrees of this. So don't be surprised if you have something down in the 10s or 20s or something up in the 70s or 80s. Okay? There will be a video in the description that includes 6 more worked examples if you need some more help. There's also going to be a link down in the description for an accompanying worksheet so you can get some practice at doing these problems.